Hello, welcome back to my channel. In today's video, we will discuss clustering. Let's get started. Clustering refers to the grouping of records, observations, or cases into classes of similar objects. A cluster is a collection of records that are similar to one another and dissimilar to records in other cluster. The clustering task does not try to classify, estimate, or predict the value of a target variable. Clustering. Clustering algorithm seeks to segment the entire data set into relatively homogeneous subgroups or cluster, where where the similarity of the records within the cluster is maximized and the similarity of records outside the cluster is minimized. The clustering is often performed as a preliminary step in data mining process, with the resulting clusters being used as further inputs into a different technique downstream, such as neural networks. Due to the enormous size of many present day databases, it is often helpful to apply clustering analysis first to reduce the goal, the identification of groups of records such that similarity within a group is very high, while the similarity to record in other group is very low. Clustering differs from classification in that there is no target variable for clustering. Examples of clustering tasks in businesses and research include target marketing of a product for a small capitalization business that does not have a large marketing budget. Second, for accounting auditing purposes, to segment financial behavior into beginning and suspicious categories. For gene expression clustering, where very large quantities of genes may exhibit similar behavior. There are many different clustering methods, including hierarchical clustering. Here we shall focus on the K-mean clustering algorithm. The K-mean clustering is an unsupervised machine learning algorithm which groups the unlabeled data set into different clusters. The K-mean clustering algorithm is a straightforward and effective algorithm for finding cluster in data. The algorithm terminate, terminates when the centroids no longer change. The steps of K-mean algorithm ask the user how many clusters K the data set should be partitioned into. Step 2. Randomly assign K records to the initial cluster center locations. Step 3. For each record, find the nearest cluster center. Thus, it is a sense each cluster owns a subset of the records, thereby representing a partition of the data set. We therefore have clusters C1, C2, K. For each of K clusters, find the cluster centroid and update the location of each cluster center to the new value of the centroid. Step 5. Repeat step 3 to 5 until convergence or termination. These are the steps of K-mean clustering algorithm. For example, the point 1, 1, 1, 1, 2, 1, 1, 3, 1, and 2, 1, 1 would have centroid 1 plus 1 plus 1 plus 2 upon 4, 1 plus 2 plus 3 plus 1 plus upon 4, 1 plus 1 plus 1 plus 1 plus upon 4 equals to 1.25, 1.27, 1.1. This is the code For K-mean clustering algorithm, here first we import few libraries. Pandas SPD, sklearn.preprocessing import standard scalar from sklearn.cluster import k-means import matplotlib.pyplot as plt. Here sample data set encoded categorical variables as numeric for clustering. Here we converts categorical variable into numeric dummy variables. Scale the data. Scalar equals to standard scaled data equals to scalar dot fit transform wine data encoded. Here we standardizes the data to ensure all features contribute equally to all to the cluster. Here we perform k-mean clustering. K-mean equals to k-mean and clusters to random state 42. K-mean dot fit scaled data. Assign cluster label. Add a new column cluster to indicate the cluster assigned to each data point. Here we print the clustered data. Plot the data point in 2D space based on their scaled values. Colors indicate cluster membership. Here we visualize the clusters. Click on run button. Yeah, this is the output of k-mean clustering algorithm. High cluster इसका 0, low high cluster 0, high low 1, low 1. Thank you.